Hello everyone, you are welcome to 2023 NECO Physics Past Question Solution Series, and here we are in question 15 to question 11 to 15. We've done question 1 to 5, so we're going to start from here today. So we're going to start from question 11, and question 11 says Figure 3.2 shows 5 positions of a bob of a swinging simple pendulum. So, at which of these positions does the bob have maximum potential energy? This question is simple, but you should know that potential energy actually depends on height, mgh, the energy possessed due to position or configuration, right? Here, if you look at it, let's assume here is the initial position of the bob before it was displaced, right? So we are going to make reference from here down to the initial position. Here is the height. Now here we have another height, but when you compare it with this one, you see that the maximum height is here. So the bob attain maximum velocity when the height is maximum. So therefore the correct answer here is option A, which is 1 only. Question 12 says, which of the following sets comprises first and second order levers respectively? I want you to understand or mark this respectively. This implies that first order must come before second order, right? So to start with, what is first order lever? First order lever is a situation where the fulcrum or the pivot or the axis of point of rotation is between the load and the effort. So example is a scissors. Here is your scissors, something like this, and here is where it actually moves, and you put your load like a piece of cloth here, and you apply your effort from here. So this is a first order lever. Another example is plier, claw hammer, etc. So second order lever is a situation where the axis of rotation, the load is between the axis of rotation and that of what effort. Example is your wheelbarrow. Here is the wheel, right? And here is where the load is, while the pushing force is applied from here, known as the effort. So in that case, we have first order lever. Example is claw hammer and wheelbarrow, which is second order lever. Therefore, the correct option is option A. Question 13 says, which of the following energy resources can be used to generate electricity without the use of a turbine? We have turbine in wind energy generation. We have water hydropower in wind. We need turbine in water, that is hydropower. Tidal, we also need turbine. The only one here on here we don't need turbine is what? Solar energy generation. There's no need of turbine in solar energy generation. Are we together? Now question 14 is calculation. The question says a body of mass 3 kg moving with a velocity of 10 meters per second collides with a stationary body of mass 1.5 kg. If the body moves together after the impact, calculate the common velocity. This is a situation of inelastic collision. So here the first body, we call it M1, which is equal to 3 kg, right? And the next is that it is moving with a velocity of 10 meters per second. That is the initial velocity of the first body, which is 10 meters per second, collide with a stationary object body of mass 1.5 kg. Then we have another body of mass, call it M2, of mass 1.5 kg. Since they say the body is stationary, it implies that the initial velocity of that body u is equal to 0 meter per second. Then what else? We asked to calculate the common velocity, so which is a v. The common velocity is gotten from the fact that the final velocity of the mass 1 is equal to the final velocity of the second mass, so is equal to v. That is the common velocity because they stick together, they coalesce after impact. So remember momentum. So we're going to have total initial momentum, momentum is equal to total final momentum. So that will be m1 u1 plus m2 u2. This is the total initial momentum, is equal to v into bracket m1 plus m2, since they have common velocity. So what is m1? m1 is 3 multiplied by u1. u1 is 10 plus m2, which is 1.5, multiplied by u2, which is 0, is equal to v into bracket 3 plus 1.5. Are we together? So then the next thing is multiply. Just simplify it. 3 times 10, that gives us 30 plus 0 is equal to v into bracket 3 plus 1.5, that gives us 4.5. So here 4.5 times v, that is 4.5 v, is equal to 30. So in that case, what we do is to divide both sides by what? By 4.5. 4.5 divided by that, then 30 divided by 4.5. As simple as that. This one will cancel this, then we'll be left with v is equal to what is 30 divided by 4.5 should give us 6.67 meter per second. So let us look at our option. Our option here, you have 6.7, so which means we can approximate here to be equal to 6.7 meter per second. That is option what? That is option C. Option C is the correct answer. So the next question, which is question 15, says, how much heat is required to convert 6 grams of water at 90 degrees Celsius to steam? So we are looking for the quantity of heat required to convert such amount of water at 90 degrees to steam. So you are given that. So in calculating this, we are given that the mass of water m is equal to, let's say, mass of water is equal to 60 gram. We are going to convert it because our specific capacity of water is in joule per kilogram per Kelvin. So convert it to kilogram, that will give us 60 divided by 1000, which is 0.06 kg. Is that correct? So theta, temperature of water is equal to, that is theta W, is equal to 90 degrees Celsius, right? Okay, then let us talk about the heat required to raise the temperature of water from this 90 degrees Celsius to 100 degrees Celsius. You know why? Because before we can get to steam phase, the water must got to what? Must get to 100 degrees Celsius. Am I communicating? So therefore let that heat be H, right? Let's call it H1. That will be MC changing theta. So we now have mass of water is 0.06 multiplied by specific capacity of water is 4,200, then multiplied by what? By change in temperature. This time around to be 100 minus what? 90 degree. Close the bracket. So when you do that, you're going to have a 0.06 multiplied by 4,200, then times what? 10. 100 minus 90. So that will give us what? 2,520 joules. So this is the quantity of heat required to raise the temperature of water from 90 degrees to 100 degrees Celsius. Once the water gets to 100 degrees Celsius, there will be, there will be a kind of latent heat of vaporization where the temperature is constant, but what? There's a change of phase from liquid phase to vapor phase or steam phase. Are we together? So now we'll be talking about the heat required to convert this water at 100 degrees Celsius. It is now at 100 degrees Celsius, right? To convert it to at 100 degrees Celsius to steam at the same 100 degrees Celsius, to steam at 100 degrees Celsius. So you see, that's what I'm talking about, phase change at constant temperature, latent heat of vaporization at this point in time. So that is the quantity of heat. Let's call it H2, the quantity of heat to convert water at 100 degrees Celsius to steam at 100 degrees Celsius. We call it H2. So that will be equal to MC change in theta as well. Am I communicating? So no, that will be the mass multiplied by, that will be the mass multiplied by latent heat of vaporization. Are we there? So this will be equal to the mass of water is 0.06 multiplied by the specific latent heat of vaporization is 2.26 times 10 raised to power what? Raised to power 6. Okay, when you multiply this together, that should give us 135,600 what? Joules. I hope we are together. Now, the total heat now is what we are going to calculate. Total heat required to convert water to steam will now be equal to H1 plus H2. That will be equal to what? What is our H1? H1 is 2,520 joules plus H2, which is 135,600. When you add this together, that should give us 138,120 joules. So let's check our answer. Let us convert it to standard form. That will be converted to standard form 1, 2, 3, 4, 5. That is 1.38 times 10 raised to power 5 joules. I hope this is understood. So looking at the options here, I think the correct option here is what? Is option D, which is 1.38 times 10 raised to power 5 joules. I hope this is understood. So we are going to stop here today. In our next class, we will continue from question 16. Thank you for your time. Please, if this is your first time to stop by, please ensure you subscribe